All right, welcome everybody. Today we're going to be working on pages 7 and 8. So previous to this, we've talked about kinetic and potential energy concepts. Now we're going to take those concepts and we're going to apply them mathematically. So one of the first things that I want you to do, so you don't have to continue flipping back and forth, is somewhere at the top of your page, I want you to write the equations that we've learned so far. So the first equation we'll write is for kinetic energy, where kinetic energy equals the mass of the object times its velocity. It's 1/2 times the mass times the velocity squared. And our potential energy, which is dependent on the height of the object, is mass times gravity times height. And we're going to use a positive 9.8 for my value of gravity because potential energy is not dependent on direction. And one other thing that I want you to remember is that the potential energy at the top is equal to the kinetic energy of that same object at the bottom of its pathway. So remember, energy transforms from potential to kinetic or vice versa depending on where the object is or how fast it's moving. Okay? So let's look at number 1. I'll do a couple examples with you and then give you some time to work on it individually. Number 1 says a car's velocity has doubled. This causes the kinetic energy to do what? Well, if you look at your kinetic energy equation, we're talking about the velocity here. And you'll notice that the velocity in your kinetic energy equation is squared. So that means any component of V will be squared. Okay? So if I take, let's say my velocity is 1. If my velocity is 1 and I square it, then 1 squared becomes 1. Okay, I'm looking at kinetic energy in relation to the velocity. If the velocity is 1, then 1 squared becomes 1. But if I double my velocity, so instead of 1, now I'm going to double it to 2. Now don't forget that your velocity is squared. So 2 squared becomes 4. So when I double my velocity from 1 to 2, it causes my kinetic energy to go from 1 to 4. In other words, my energy has quadrupled. All right, so when I look down here at number 2, I'm comparing 2 bullets. And it tells you here that they have a mass of 0.003 kilograms and a mass of 0.006 kilograms. Now both are fired with the speed of 40 meters per second, so they have the same velocity. So same velocity, but they have different masses. So what it's asking you here is which bullet has more kinetic energy. Okay, so think of it this way. Kinetic energy is dependent on the velocity of an object. If they are both moving the same velocity, then that's not really going to determine which one has more or less kinetic energy. In your equation, kinetic energy equals 1/2 mass times velocity squared. So if the velocities are the same, then your next factor becomes mass. So we talked about this in the notes, that as I increase the mass, then I increase kinetic energy. There's a direct relationship between mass and kinetic energy. So in other words, when the mass goes up, that leads to an increase of kinetic energy. So now all you have to do is identify which bullet has the greater mass, and you'll notice that it's the 0.006 kilogram bullet that has the most mass, therefore it has the most kinetic energy, considering they're both going the same speed. Okay, let's see here. Let's look at number 3, total mechanical energy of a system that contains 80 joules of potential energy, 60 joules of kinetic energy. So total mechanical energy is sometimes abbreviated TME, or it might be abbreviated ME for mechanical energy. It's the sum of potential energy plus kinetic energy. So total mechanical energy equals PE plus KE. Okay. Let's go ahead and add that to the top. I forgot to add that a second ago. So at the top of our page, we're going to write TME equals PE plus KE. All right, so now number 3, what's the total energy? Well, it tells me I've got 80 joules of potential energy. So we've got 80 joules of potential energy and 60 joules of kinetic energy. So my total mechanical energy is 60 plus 80, which gives me 140 joules of total mechanical energy. All right, so for the next couple, I'm going to give you some hints, but I will allow you to solve them on your own. Looking at number 4, what is the kinetic energy of a 3 kilogram ball that's rolling at 2 meters per second squared? So it's asking you to find the kinetic energy. So you want to find KE, and it gives you 3 kilograms, which measures mass, and it tells you it's rolling 2 meters per second, which is the velocity. So if you remember, your kinetic energy equation is 1/2 times mass times velocity squared. So you plug in your mass, your velocity, and solve for KE. I'll let you solve it on your own. And number 5 says the potential energy of an apple is 6 joules. The apple is 3 meters high. What is the mass of the apple? All right, so it's telling you now the potential energy is 6 joules. So it's telling you PE. It tells you the apple is 3 meters high. So this is a vertical distance, and in this case, it's height. And it wants to know what is the mass. So you're solving for variable M. So your potential energy equation, based off what we wrote at the top, is PE equals mass times gravity times height. Plug in your mass. You're solving for mass. Plug in potential energy. Plug in your height. Remember, gravity is a positive 9.8. And solve for M. Okay. On the right side here, I'm going to let you work on some of these equations. I will give you a hint, though, for number 7. The potential energy at the top will be equal to the kinetic energy at the bottom. So keep that in mind when you're solving for number 7. All right, then when we look down here at number 9, it wants to know the difference in gravitational potential energy. So in other words, you want to know the difference in potential energy. So difference means subtract. Okay, over here you've got a mass, a box. It's got a mass of 2 and a height of 3. And over here you've got another box with the same mass but with a new height. Okay, using your potential energy equation, I want you to figure out the potential energy of each and then find the difference, the total difference. Okay, let's see, moving on, let's look at the back page on page 8. All right, so here is what we've got on page 8, and it looks like a lot, but if you can remember certain concepts, that'll make solving this relatively easy. So one thing that I want to mention first of all is that this is not drawn to scale. Okay, and the reason being, you might look at the position of the ball and have an idea of what the potential or kinetic energy may be, but keep in mind it's not drawn to scale, so the numbers might not coincide with the exact position of this ball. But overall, it's a good conceptual tool. We have a ball here that's at its highest point, and it's going down this hill, down this ramp, up and over. Here's its pathway. It's forming a curved pathway because it's moving horizontally and vertically at the same time, and it lands at this position. So you notice at each position, I'm only given limited information. Like at this highest point, it tells me that the height is 100 meters and the velocity is 0. At this point, it tells me the potential energy is 34,300 joules and no other information. At this point, it tells me the velocity of the ball is 40 meters per second. And here where it hits the ground, I don't have any information. Okay? So, let's think about this a little bit. My object here is at its highest point. So anything that's at its highest point, especially if it has a velocity of 0, it's going to have all potential energy. If it has a velocity of 0, then that must mean that the object is not moving, and the kinetic energy must also be 0. So that is something that we can fill in right off the bat. If your velocity is 0, and I plug this into my kinetic energy equation, then my kinetic energy will also become 0. So I've got 0 joules for kinetic energy, which means all of my energy has to be potential energy. So think about how you solve for potential energy. Potential energy is mass times gravity times height. Okay? So mass of the ball is 70 kilograms. Gravity, we're going to calculate it as a positive 9.8, and the height is 100 meters. So 70 times 9.8 times 100 meters. I'll give you a second to calculate it. You can pause this video if you'd like to. So mass times gravity times height, 70 times 9.8 times 100 gives me a value of 68,600 joules. So all the energy that this ball has is in the form of potential energy, and it totals 68,600 joules. So the total mechanical energy is 68,600 joules. So if you want to add that, total mechanical energy is 68,600 joules. So what does that mean? Well, that means that at any point along this object's pathway, the potential energy and the kinetic energy will always add up to 68,600. Okay? So 68,600 plus 0 gives me 68,600. When I look over here, it gives me the potential energy as 34,300. Well, I know the total energy is 68,600, so that means that 34,300 plus what has to add up to equal 68,600. Okay? So remember, total mechanical energy, TME, equals PE plus KE. If my total energy is 68,600, my potential energy is given to me, it's 34,300. What is the value of the kinetic energy? So all you're doing is you're solving for KE by moving 34,300 to the other side by subtraction. And when you subtract 68,600 by 34,300, you get a kinetic energy of 34,300 joules. This 34,300 plus 34,300 add up to equal 68,600. So what this is showing me is that at this point, the object is approximately halfway down its path. It's halfway between the highest point and the lowest point down below. Okay? So with that information, with the potential energy and kinetic energy, now you have the factors here that will allow you to solve for height and velocity. Okay? Think about your equation that has height. It's mass times gravity times height equals potential energy. To solve for V, it's KE equals 1/2 mv squared. Okay? So, let me write this. For number 14, height is potential energy equals mass times gravity times height. Solve for h. You have potential energy up at the top. For number 15, velocity. Velocity is a factor of kinetic energy, so Ke equals 1/2 mv squared. Solve for v. Okay. Moving on, number 16 and 17 and 18. So at this point, it gives me only the velocity. That's all that it gives me. Well, I know that velocity is a factor of kinetic energy. So I can solve for my kinetic energy by plugging V and M into my equation. And M was given to you up above. It was 70 kilograms. Okay, so that gives you kinetic energy. Remember, kinetic energy plus potential energy equals 68,600. So if you can solve for Ke, then you can solve for Pe. So let's solve for Ke. Ke equals 1/2 times the mass, which was 70, times the velocity, 40, squared. So I'll give you a second. I want you to calculate this. Go ahead and pause the video. All right, so hopefully by now you've calculated on your own instead of waiting for me to give you the answer. When you calculate 40 squared times 70 times 1/2, you should get a kinetic energy of 56,000. So my kinetic energy is 56,000 joules. So you know the potential energy has to be something that adds up to 56,000 to give you 68,600. So total energy equals Pe plus Ke. Total mechanical energy is 68,600. Potential energy is unknown. Kinetic energy we just solved for is 56,000. Solve for Pe. Once you have Pe, then you can use your potential energy to solve for height. Okay, and moving on, looking at the last point here, I don't have any information given to me, but I do know the position of this ball is at its lowest point. So what that means, if it's at the lowest point or the lowest height, then I can assume that my height is 0. If your height is 0, think about what form of energy is dependent on height. It's potential energy. If your height is 0, then your potential energy is also 0. If your potential energy is 0, then that means that all the energy that that ball has to be kinetic energy. So the potential energy at the top has to equal the kinetic energy at the bottom. So the potential energy at the top, at the highest point, was 68,600. Therefore, the kinetic energy at the bottom has to also be 68,600 joules. And I know this because 68,600 plus 0 equals 68,600. And your last step here is solving for velocity. Kinetic energy is dependent on velocity. You know the mass, you know the kinetic energy, solve for V. So use this time, the rest of the period, to go back and answer any remaining questions on page 7. Once you complete those on page 7, complete any unknown information on page 8. If you need to go back and look at previous videos that I posted or any previous notes that you've taken, please do so. But spend your time wisely, work diligently, limit the cell phone use, work on pages 7 and 8.